Good morning. Today we are going to see about the MVA-Mile method in the restructured power system. In the previous class, we have seen about the megawatt-mile method. Here we are calculating the apparent power also. So MVA-Mile method is an advanced transmission pricing technique used in the restructured or deregulated power system. Unlike megawatt mile methods that consider only active power. So megawatt mile method consider only active power, that is in megawatt. So this MVA mile method allocates the transmission cost based on the apparent power MVA, which includes real power and as well as the reactive power. Since transmission lines are thermally loaded by MVA, this method gives more realistic and fair cost allocation. So, in the MVA mile method allocates the transmission cost based on the apparent power flow. That means MVA, considering both real power and as well as reactive power, multiplied by the line length, thus reflecting the actual network loading and providing fair cost allocation in the restructured power system. Whereas in the previous megawatt mile method, only we have used only active power, that means megawatt only, that is multiplied with the line length and with the cost. But here we are using the real power and reactive power, and which is multiplied with the line length and as well as the cost calculation we are going to do. Why this MVA mile method is needed? So now we need to know what are the limitation of megawatt mile method. In megawatt mile method, it ignores the reactive power, which does not reflects the voltage support also, and also it underestimates the line loading and as well as the losses. Now, why we need to give the importance to this reactive power also? That means reactive power. That means apparent power, which consists of real power and reactive power. So here only real power is there. Here reactive power. So while we need to give the importance to reactive power, means if you not give the reactive, give the it affects the voltage profile. If you not give the importance to it, it affects the voltage profile, increasing the line current. Okay, increased line current and raises the losses and as well as the congestion. So we need to give the importance to this reactive power by considering all this factor. Hence, MVA mile method better represents the actual network usage. Okay, because sudden rise in the line current. Okay, so that calculation also needed, and voltage profile calculation. Next, losses, raises in the losses and congestion, that also should be included if you include the apparent power also. So what is the basic concept of the MVA method? So transmission cost is allocated based on the actual line loading, that is MVA, and also as well as the distance traveled, that is in miles or kilometer. So how to calculate the cost per MVA mile? So MVA is equal to root of megawatt square, that means real power square, plus reactive power square. Or otherwise, apparent power S squared is equal to P squared plus Q squared. So here directly we are using that units. Okay, that is MVA is equal to root of, or MVA squared is equal to MW squared plus MVAR squared, or MVA is equal to root of MW squared plus MVAR squared. So how this MVA mile method works step by step. Step one, yeah, by using the AC power flow analysis. That means Newton-Raphson method, either by using Newton-Raphson method or fast decoupled load flow method. So this already we have discussed in detail in our previous classes. If you are not aware of this Newton-Raphson and fast decoupled method, you just go through in our YouTube channel. Now, determine MW and megawatt and MVAR flows on the each line. That is the step number one. So by using the AC load flow analysis, we need to determine the megawatt and MVAR flows on the each line. How to calculate line MVA? So line MVA of the particular transmission line MVA I is equal to root of megawatt I square plus MVAR I square. I is nothing but that particular transmission, ith transmission line. Now compute the MVA miles. So MVA miles I is equal to MVI into line length I. So how to do the cost allocation? So cost allocation, transmission charges. How to calculate the transmission charges in the sense that transmission charges equal to summation of MVA miles. That means this one. MVA miles equal to this MVA into line. Okay, line length, say for example, 200 kilometers or 100 kilometers. So whatever the line length given in the problem, that you need to take. So transmission charge is equal to MVA miles into unit cost. Okay, so MVA mile this one into total MVA mile into unit cost. This is ith transmission. So you need to add for how many number of transmission line, that summation you need to take here into unit cost. So these are the steps for calculating the this MVA mile method. So just a conceptual block diagram. So here yeah. So power transaction that is happening in the GENCOs and DISCOs. That AC power flow analysis. So in that AC power flow analysis, we are calculating the megawatt and MVAR calculation. Next, how we are calculating the apparent power calculation in the sense apparent power calculation MVA is equal to root of MW square plus MVAR square. Now, for line length also we need to. So MVA mile for each line is nothing but MVA into line length in miles. Now, after that, we need to calculate the transmission cost allocation. That means dollars per megawatt MVA mile. So that into that particular transmission cost also we need to calculate. Okay, so this is a simple block diagram of this MVA mile. This is the simple block diagram of this MVA mile method or conceptual block diagram of the MVA mile method. Now, for this, understanding this MVA mile method in a better way, so I did a simple numerical illustration. Assume that MVA flow as 100 megawatt, MVAR flow, that means reactive power flow as 60 MVAR. Next, line length you take as 80 kilometers. Okay. Next, cost per rate is rupees 5 per MVA kilometer. Like that you take. So first step is to calculate MVA. So MVA of either transmission line, what is the formula? Root of MW square plus MVAR square. So MVA is equal to this megawatt. Megawatt is what? 100 megawatt. MVA flow is 100 megawatts. So 100 square plus MVAR is 60 MVAR. 60 square. So if you simplify this, you'll get the answer as 116.6 MVA. That is how we need to calculate the this particular MVA. Next, per kilometer, MVA per kilometer, because 80 kilometers is given. So into 80 into length of the line. So MVA kilometer. MVA kilometer. That means this 116.6 into 80. So if you calculate 9328 MVA kilometer is coming. Now we need to calculate the cost. Okay, so cost per MVA kilometer also given, that is 5 rupees. So this 9328 into 5 rupees, you'll get the 46,640 rupees. So this is how you need to calculate the cost of MVA mile method. Okay, so this is for mile. So this is for kilometer. You can also, if you want, you can do it in mile also. Okay, so you can convert that kilometer into mile also. Nothing wrong. So what are the main advantage of this MVA mile method? So this considers both the megawatt and the MVAR and reflects actual thermal loading, accounts for voltage support also, fairer wheeling charges also available, suitable for deregulated market, because here we are considering both the megawatt and the MVAR because we are calculating MVA. So it reflects this thermal actual thermal loading, how actual thermal loading that also it reflects, and also it accounts for voltage support. So wherever voltage support is required, so that weak zones we are monitoring, and their voltage support we are increasing, and fair transmission wheeling charges. That means transmission wheeling charges already discussed in detail. Next, suitable for this region. These are the deregulated power market. So these are the advantages of the MVA mile method. So what are the main limitations of this MVA mile? It requires AC load flow analysis because complex analysis. Already in our YouTube channel, we solved the AC load flow analysis. That is for only three bus system we solved. So three bus system itself, minimum it took half an hour, more than half an hour for solving. So if the number of buses increases, the complexity gets increased. And you need to choose the dynamic algorithm for calculating that particular. So computationally intensive, that is also there, may not fully capture counter parallel flows. That is also one limitation is there. Data is intensive. Now we are going to compare this MVA mile method with the other methods. That means postage stamp method, megawatt mile method, and signed megawatt mile method. So in the postage stamp method, obviously megawatt we are not doing. Calculating MVA also not good, distance also so accuracy is low. In MVA mile method, we are calculating megawatt. MVAR we are not even discussing. So distance we are calculating, accuracy is medium. So signed megawatt mile method, also megawatt we are calculating, MVAR not calculating, distance also the accuracy is somewhat high. And MVA mile method, this three we are calculating. Megawatt also we are calculating, MVA also we are calculating, distance also we are calculating, and accuracy is very, very high when compared to all other methods. So that's why MVA mile method is one of the successful model when compared to all other three methods.